In this video, I am going to explain you about thermistors. Now, thermistors are nothing but elements with higher temperature dependence over resistance. Now, we know that with conductors, when temperature increases, resistance will also increase. Now, if the change in resistance is very high with a slight increase in temperature, then that conductors cannot be used in devices, because when the temperature increases from morning to noon, what will happen? The performance of devices will vary because the resistance of all the element has got changed now. But these elements, these thermistors, which has got highest temperature dependence, can be used to measure temperature and to protect devices against temperature. I will explain you how that is possible. Let's say this is a thermistor now. So a slight change in temperature will vary its resistance. Now, if we are connecting the thermistor with a device, with a power, we know what will be the current going. I is equal to V by R. Now, there is a small change in temperature, there will be a huge change in resistance, and it can be clearly measured with an ammeter or with any device that the value of current will change, which means 27 degrees Celsius to 28 degrees Celsius, a slight increase. That will be a good change in resistance, and if resistance changes, current will also change. So a small change in temperature can be easily measured with this device. Now, how can we measure it? We will calibrate this device. We will check, okay, resistance value of 100 ohm means 27 degrees Celsius. Now, if it become 105, that is 28 degrees Celsius. That process is called as calibration of the device. Now, these thermistors we will keep, inside mouth or wherever we have to check the temperature. Then, when this is inserted to the part where we are checking the temperature, this part will also get the same temperature of the place where we are going to. So, let's say I am going to keep it with a pot, with a hot pot inside the pot, okay. Inside the pot when I am keeping, then whatever the temperature this pot is having, our thermistor also will get the same temperature. Now the resistance of the thermistor has got changed. Now this change in resistance will give rise to a change in current. Now this current will represent a particular temperature, and this temperature will be displayed in the digital meter. So simply, small change in resistance gives a value of change in current, and that change in current is now calibrated to certain value for temperatures. So this way we can measure temperature. Now I will explain how we can use this to protect devices against temperature. Let's say we have a circuit in this way. This is the circuit, a refrigerator circuit, for example. Okay, so a refrigerator is connected in this way, and this is one end of the conductor, one terminal, and this is another terminal of the refrigerator, for example. Now these are connected by a metallic strip over here. Now this, let's say this is a T-shaped rod. Now when the T-shaped rod is coming down, then the circuit will be opened. See, when the T-shaped rod is coming down, this circuit is open, the current will not be sent. Now when the T-shaped rod is here in contact, then the current, this circuit is closed. Now current can go through this element and also through the refrigerator. Okay. Now what we will do, we will connect this plunger, I am going to call it as plunger, with an electromagnet, and this is a thermistor. Okay, so this is also powered. I am going to connect with a battery. So what will happen? When I am going to connect with a source, there will be current passing through this. Clear? Okay. Whenever there is current passing through this will behave as an electromagnet, and electromagnet will push or will lift the T-shaped plunger upward, so that there is a connection in between. This will make a connection in between these two terminals after closing the circuit. So with the plunger, this whole circuit will be closed. There will be current passing through this. Now when the temperature of the refrigerator increases, what will happen? The resistance value will also increase, because this refrigerator is connected to this thermistor directly in contact. So whatever the rise in temperature, that will also affect the thermistor. When the resistance varies, what will happen? we know that for the whole circuit I can use this equation. I is equal to V by R. Now when resistance increases, the current decreases. Now when current decreases, what will happen? The plunger will be now less magnetized, so that this electromagnet will be less magnetized, so that this magnet cannot lift the plunger upward, so the plunger will come downward. Okay, now the plunger is downward, so that this circuit is open. So at higher temperature, the plunger comes downward and circuit is opened, thereby it protects this device. Now whenever the temperature is lower, again resistance will come up, when the temperature is lower, resistance will go down, current will increase. When current increases, this will be more magnetized and it can lift this plunger, thereby closing the circuit. Thank you.